All right, guys. I am very sorry that I was not able to be here today. I had some serious car issues, was not even able to get my car to start even after jumping it late last night. Did not find it out until late last night, and so I'm running around today trying to figure out either how to get my car fixed or how to get a new one. What we're going to do is we're going to push everything back a day. So what we are going to actually talk about today would be the notes we would be starting on. Originally, we were going to do on Thursday, but since we're pushing everything back, the quiz, which was going to be on Wednesday, will now be on Thursday. So to not kind of waste a day in class, I'm going to give you some of these notes. There's not going to be any homework or anything to go with these. I want you focusing on getting ready for the formative assessments on Wednesday and then the quiz on Thursday on targets 1 and 2, but we can at least get the notes started in target 3 so that we get that ball rolling and don't fall too far behind. All right, so what we're moving into in target 3 is simplifying polynomial expressions through addition and subtraction, and then in part 3b, multiplication. Before we get to that, though, we've got to talk about some new vocabulary. There's going to be some new terms that we have to make sure we are clear on, because they will play a big part in writing answers in a correct form right now in algebra, and then when we get to AAT, they're going to play a big part in understanding different types of polynomial functions and other types of functions as well. So let's dive right in here. The word degree. Now, we've probably heard the word degree before. It's an antiperspirant. Temperature degrees, angle measures degrees. So we're going to throw one more new definition in there for the word degree. When we use the word degree and we're talking about our polynomials, we are talking about the sum of the exponents of the variables of a term of a polynomial. I know that's a lot of ofs, and I would like to simplify that if I could, but that's the best we got. So essentially what you do is you're going to add, right, because sum means addition, all the exponents of the variables, and you add that up and you're going to get a number, and that number is its degree. Think of that as the measurement of the term. The bigger the degree, the larger the measurement, the smaller the degree, the smaller it is, right? Now, that's just of an individual term. A polynomial, as you can see this example below, is a lot of times made up of multiple terms. So if each term has its own degree, how do we determine the degree of a polynomial as a whole? Do we have like a cage death match between all of the terms, and the term with the largest degree comes out on top? Well, pretty much actually that's exactly what we do. The degree of the polynomial is the largest degree of any term in the polynomial. So we don't care about any terms if they have a degree smaller than the largest. When we talk about the degree of an entire polynomial, whatever's the largest wins. All right, and I know that's I don't know, maybe not politically correct, but it's the way it goes. So when we look at this term here, this first term, we look at it and it has degree exponents of 3 and 2, so the degree here would be 5. And then we look at the second term, negative 6x to the third. Well, the only exponent here, only variable is 3, so that degree is 3. Then I'm going to look at my next term here, 2x to the 6th, y to the third. 6 plus 3 is a degree of 9. Now, 14 has no exponent. If we have no exponent, that's really like having an exponent to the 0 power. So a constant will always have an exponent of 0. And my last one, negative 11x to the 5th, well, there's only 1, so I'd have a degree of 5. So we can see these are the degrees of each individual term, 5, 3, 9, 0, 5. Now, as far as the degree of the entire polynomial, all right, we don't care about the 5, the 3, the 0, and the 5. What we care about is the largest. So that middle term there, 2x to the 6th, y to the third, would give us not only does it have its own degree of 9, but since it's the largest, it also counts as the degree of the entire polynomial. All right, and that's, again, something that's going to be important. Now, writing your answers is something we're going to expect you to be able to do in what we call descending order. Descending order, as you've probably heard, descending means you're starting with the largest and working your way down to the smallest. And when we talk about largest and smallest, we're not talking about height, we're not talking about weight, we're not talking about how fast you can run, we're talking about the degrees of the term. So we're going to take all the terms, measure their degrees, and then order them from largest to smallest degree. We'll do a couple examples of these in a second here. The leading term is the first term in descending order. This would be the term that has the highest degree. That's the term that gets to go first. The leading coefficient, very obviously, is the coefficient of the leading term. So whatever coefficient, whatever term comes first, that coefficient would be there. All right, so let's take a look here. Descending order. So if I look at these three terms, my first term, don't forget your ninjas. This has a degree of 1. I here have a degree of 2 and then 0. So if I'm going to write this in descending order, my degree 2 goes first, my degree of 1 goes second, and then my degree of 0 goes last. All right, let's take a look at a little longer one here. So I have a degree of 2, a degree of 3, a degree of 5, a degree of 0, a degree of 1, and then a degree of 4. All right, so 5 is the largest, so that one's going to go first. Then 4 would go next, then 3, then 2, then 1, and then 0. So that would be this polynomial. Oops, sorry for the losing the line there. That would be this polynomial in descending order. All right, well, let's take a look at a couple more examples here. If you want to pause and try these last two on your own and then check, go right ahead. Now, don't forget your ninjas. This is a degree of 4, 1 plus 3. Ninja, this is a degree of 1. Here's a degree of 2, a degree of 0, and a degree of 2. So clearly, the 9xy to the third goes first. But what comes second? Notice I have two terms with a degree of 2. If you are not given a specific variable to focus on, then it doesn't matter which comes next. So x comes before y in the alphabet, so I'm going to put x squared before y squared, but it would not matter which of these two terms with the same degree you put first. Then a degree of 1, and then my degree of 0. All right? And my last one here, notice degree of 7, degree of 5, degree of 2, and degree of 0. Look at that, 7, 5, 2, 0. It's already in descending order, so I don't actually have to move any of the terms around. It is already in descending order. All right, one really, really important thing we've got to keep track of, which always trips some people up, because the first number you see in a term is the coefficient, and a lot of times people want to put them in order based on the size of their coefficient. Coefficients have nothing, I'm yelling at you with big capital letters here, nothing to do with the expression's order. All right, the order of the terms has nothing to do with the coefficients. It's all about the degree, which comes from the exponents of the variables. All right, so let's quickly talk about adding and subtracting here, and then tell you what I'm going to do. I will do these examples in notes on real-time board, but I'm not going to do them on the video just to save us some time here. So if you want to know what the answers were for 1 through 4 over here, check real-time board. The work will be there. So adding and subtracting, really, really simple, because you actually already know what you need to do. Because all adding and subtracting polynomials is combining like terms. Now, like terms are terms with the same variable, but also the same with those same exponents. So it's not enough just to have the same variable, they've got to have the same exponents. So just a quick example here, 7x squared and negative 4x squared are like terms, all right? And then just to show you a situation that's not good, 8y and 3y squared are not like terms, right? Because this has an exponent of 1 and that has an exponent of 2, those would not be like terms. So adding is really simple. Adding is just finding any like terms that you have in the expression and combining them. So let's start, x cubed, all right, no other x cubes, x cubed, oop, there's an x cubed. Notice I included the operation sign with the term that it followed, so those are attached. So positive 4 plus 6 gives me 10x cubed. Let's cross that out. All right, next up here I got y squared, y squared, y squared, oop, there's a y squared. Negative 7 plus 8 is just 1y squared. 12x, nope, no other x's. So guess what? I just bring that down. Negative 12. Negative 12, I got a 20 there, right? Let me cross those out when I've used them. So negative 12 plus 20 is going to be positive 8. And then 3xy, oops, negative 7xy. So 3 plus negative 7 gives me negative 4xy. So I have now simplified the expression, but notice this is not written in descending order. This is a degree of 3, a degree of 2, a degree of 1, a 0, and 2. So I need to rewrite this. I need to make sure I write the negative 4xy. Again, don't forget about the ninjas there. Add up 1 plus 1 is 2. That's going to jump in front of the 12x and the 8 so that we are correctly writing this in descending order. All right, now subtraction. Subtraction is doing the same exact thing, except obviously instead of adding the term from the first polynomial, you'd be subtracting them. I'm going to show you a trick on how you can rewrite subtraction as addition. What I have found is that when people try and do subtraction, we generally make mistakes that we don't make when we're adding. Let me make this very clear. You do not have to rewrite subtraction into addition. This is only if you like doing addition and don't want to do subtraction. This is a way you can do it. All right, just want to make sure that's clear. If you like subtraction, if you're good at subtraction with negatives, then go right ahead and subtract. So a subtraction sign in front of a parenthesis is really a factor of negative 1. So what we can do is distribute the negative 1 and rewrite that expression as addition. So essentially what I'm going to do is treat that as a negative 1, and then I'm going to take this negative 1 and I'm going to distribute it to every term here. What that's going to do, by multiplying by that negative 1, I am going to take my expression, and the first polynomial isn't going to change at all. But what I'm going to be able to do now is instead of subtracting, I can add the opposites of every term here. So instead of subtracting 5y squared, I'm adding negative 5y. Instead of subtracting positive 22, I'm adding negative 22. Instead of subtracting negative 5xy, I'm adding 5xy. And my last thing would be there. All right, so now once I've done this, once I've distributed that negative 1, once I've changed the subtraction to addition, now this example is exactly the same as above here. So let's just do a different color. 6x cubed and negative 11x cubed. That's negative 5x cubed. I'm going to pick and choose here so I go in descending order from the start. Negative 3y squared and 5y squared. So that's negative 8y squared. I'm going to grab my 4xy and my positive 5xy. That will now be positive 9xy. Notice I am choosing the terms to add here so that I end up in descending order right away. Positive 9x, nothing to go with that, so it just stays 9x. And then negative 15 and negative 22 will give me negative 37. So there we go. All right, so I know I kind of sped through those notes. If you've got questions, guys, we'll come back to this on Friday after the quiz on Thursday. So write these notes down, figure out what your questions are, then take this and put it on the side. Focus on targets 1 and 2 for Wednesday and for Thursday, and then we'll come back to this, and hopefully we've got a really good head start, and we can save some time by you guys taking the notes, watching this video, and rolling this around in your brain when we come back to it on Friday. All right, again, really sorry I couldn't be in class. Trust me, I would much rather be with you guys than trying to figure out what's wrong and or trying to buy a new car. So I will see you on Wednesday, and until then, have a great one.